Okay, in this video, we're going to work the example problems at the end of the correlation coefficient section. So the first question says, would the correlation between the age of a secondhand car and its price be positive or negative? Why? Antiques are not included, so we're not talking about some classic car that gets its price, resale price gets better with age type thing. A general used car. All right, well, we would expect the correlation between the age and price to be a negative correlation. And then the next part says, what about the correlation between weight and miles per gallon? Well, that's going to be negative as well. As the weight of the vehicle gets higher, the miles per gallon is going to get lower. And as the age of the car gets higher, its resale price is going to get lower. So, okay, like in general, we would expect to see the age of the car and the price, the resale price. If you plotted a bunch of data points here, so someone sells a car at a certain price, well then how old was that car from brand new? There's a data point. So you plot a bunch of data points. In general, as the age gets higher, the resale price is going to get lower. That's a negative correlation. And then weight of a vehicle in miles per gallon, if you take any given vehicle and you see how much it weighs, and then you record also what the corresponding miles per gallon of that vehicle is, the smaller the weight, the higher the miles per, you can get better gas mileage, right? So it's going to do like this as well, negative correlation. Now, something to note, though, here is that, so, you might think, well, man, but the price of a vehicle, the resale price, we know drops off fast once you drive it off the lot, right? So, I mean, really, it could go down exponentially, not linearly. Okay, but you can still, the correlation coefficient can still be useful regardless of what the ideal function that you would use to do a correlation would be. Maybe this would be some combination of like exponential and quadratic, e to the minus x plus, so a e to the minus x plus bx squared plus cx. Maybe this is the ideal function to model the drop of price with a resale price with the age of a vehicle. That would correlate the best. But regardless of what the function is, the actual ideal function is, you can still use the classic correlation coefficient, linear correlation coefficient, to give you information. Because what you can think about is that there's no way that if there was any function in existence that would correlate at least to some extent pretty well with some data, any type of function, if that's the case, then the linear correlation coefficient is going to be non-zero, and it's going to tell you if it's a positive or negative association. The only way you can have a zero correlation coefficient, okay, so the linear correlation coefficient is zero, is if there is no pattern at all. If you get a linear correlation coefficient of zero, then that means there's no function that you could possibly come up with that's going to correlate with that data. Right? A line is going to tell you the trend of the data, the general trend of the data. You see what I mean? So the linear correlation coefficient is powerful in and of itself, regardless of how the data is shaped. If it's shaped exponentially, logarithmically, quadratically. Again, I'll say this again. If you get a linear correlation coefficient of zero, then that means there's not going to be any correlation coefficient corresponding to any kind of function. There is no correlation between the data at all. But if you did get something like, some sort of exponential decrease, well, then the linear correlation coefficient will still give you some information, right? It can tell you that there is some degree of correlation in the data, and it'll tell you if the data is positively or negatively associated. Okay, so here we've got two negative associations. In general, and this is negative as well. In general, for both of these scatter plots, you're going to see, if you put a circle around the cloud of points, it's going to be slanted negatively. All right, for each scatter diagram below, The average X is around, so these two scatter diagrams, the average X is around what? Same for Y. Okay, so let's see. They want us to just go to each one of these. All right, the average X is around 3. The average X here is around 3. So 3. The average Y is around 1.5. Maybe here would be more closer to 1. No, 1.5. So 1.5 for both. Okay, the standard deviation of the X is around, so the average is around 3. Standard deviation looks to be around 1, probably 1. I think 1.5, could be 1.5. Probably 1. You know, you see most data points are right within 1 unit away. This is the biggest cluster here, so 1. And should be the same over here. Yeah. So 1, and now for Y, so goes up to about 2. That's 0.5. Yeah, 0.5. 0.5. Is the correlation positive, negative, or 0? Okay, so positive, negative. So positive and then negative. For which of the diagrams in the previous exercise is the correlation closer to 0? Forgetting about sign. Okay. That's a tough one. I would say the left, because they're both of these seem to have the same degree of like trend, which I guess that technically doesn't matter how much it's angled, but this is more tightly packed in towards a line. This is looser, so the left. In figure 1, is the correlation between the heights of the fathers and sons around minus 0.3, 0, 0.5, or 0.8? All right, so here is that scatter plot from the previous section. All right, so it's not going to be negative for sure, right? We can see it's a positive correlation, and could it be 0? No, but I mean, it's definitely pretty spread out. I mean, you could say that it correlates around this line here. So no, it's not going to be 0. Like if we had more data points down here, then maybe so. So it's not going to be 0, but 0.8 is way too high. 0.5 has got to be the answer. 0.8, you expect it to be a lot more tightly packed around a line. So 0.5. Okay, in figure 1, if you took only the fathers who were taller than 6 feet and their sons, would the correlation between the heights be around, the same question? So, okay, let's bring this back. Only the heights taller than 6 feet. That's 72 inches. So, okay, out here. Well, yeah, that's nearly 0. I mean, what would you... This is just, there's no pattern to these dots at all. You would have no idea if someone gave you, based on these heights, greater than 72 inches, if someone gave you a son's height or a father's height, you'd have no idea what to say. I mean, other than it's going to be in this range, other than that. But in general, you'd have no idea how to predict anything. So 0 correlation. If women always married men who were 5 years older, the correlation between the ages of husbands and wives would be what? Choose one of the options below and explain. Okay, so one of these options. If women always married men who were 5 years older, The correlation between ages of husbands, age of husband, age of wife would be what? So you have an age of a woman, but the age of the husband is always 5 years more. So you're always, it might be easier to view it this way. So here's the age of a woman, you're always up here. Age of a woman, well, let's look at it this way. You've got the 45-degree line means that they're the same age. And so all this is saying is that we're always like the same distance above this line. We're like 5 units above this line. So the correlation would be exactly 1 if this was always the case. Women married men 5 years older every time. And that makes sense because it would be a perfect correlation, because if this was 100% true, if this was 100% true, then you would be able to predict. If someone gave you the age of a woman, you'd be able to say, okay, this is her husband's age, or vice versa, 100% exactly correct, 100% of the time. Okay, the correlation between the ages of husbands and wives in the U.S. is, what is the actual correlation? Okay, well, I don't know. I mean, what are they saying here? They're saying if this is true, yeah. I mean, if this was found, if a study showed that women always seem to marry men that were a few years older, around 5 years older, well, then in actuality, it would be close to 1. Right? It would be like this, where you could, if you knew a woman's age, a good guess would be to say that her husband is 5 years older, but you might not be exactly right, but it's a good guess. Investigators are studying registered students at the University of California. The students fill out questionnaires giving their year of birth, their age of mother, and so forth. Fill in the blanks using the options given below and explain briefly. The correlation between students' age and year of birth is, the age and year of birth is going to be 1. Because once you know, why am I saying that? Because once you know the students, that's not true. Or no, it is true. Because once someone gives you their age, then that fixes their year of birth. Well, okay, it might be -1. It's going to be a perfect correlation is what I'm saying. So what would it be, 1 or -1? So the student's age and year of birth, so the older they are, then how does this work? Okay, well, I guess we would start at like 19 whatever, 80 something, and then it would go up to the 2000s. So the older the student, the further down the year of birth. The younger the student, the larger the year of birth. So yeah, it would be perfectly -1. Because once you know the student's age or year of birth, then you know exactly what the year of birth is, or the age is, right? So -1. The correlation between the student's age and mother's age is, okay, student's age and mother's age. Student's age and mother's age would be, this probably would actually be linear. Even though if it wasn't linear, we still could use the linear correlation coefficient to get information. So the older the student, the older the mother. But they're not going to be, it's not going to be, it's going to be above the 45-degree line for sure, because they're not the same age, right? But the way you would look at this, it would be close to a fixed distance above the 45-degree line. So what, 25 years? That'd be a good guess, right? On average, a student's going to be 25 years younger than his mother. So it would be just some line, fixed distance, about 25 years above, but it's not going to be exactly 1, because, that can vary a little bit, but it'll be nearly 1, right? If you know someone's age, you can make a good guess of what their mom's age is. Just make a guess, something between 20 and 35 years older. So nearly positive one. I guess when you think, maybe it would be somewhat positive, because if you're off by 5 years, I guess that's a good percentage of the total age of the student. The student is 18 years old, 19 years old. If you're off by 5 or 6 years, you could, so I guess somewhat positive. Right? That total 20 to 35 year gap, that's a 15-year gap. That's almost the full age of the student, right? I said that the mother is going to be somewhere between 20 and 35 years older than the student. The student's around 18, 19 years old, so that's almost the entire age of the student. So yeah, I guess somewhat positive. It might be more, you probably have student's age, mother's age. You'd be somewhere up here, and it would probably be I guess somewhat positive. Investigators take a sample of DINKs, dual income families where husband and wife both work and no kids. Okay. The investigators have data on the husband's income and the wife's income. By definition, the family income is the husband's income plus the wife's income. So dual income families where the husband and wife both work, no kids. The average family income was around $85,000, and 10% of the couples had family income in the range $80,000 to $90,000. Fill in the blanks using the options given below and explain briefly. The correlation between wife's income and family income is, okay, so the wife's income and the family income. So I guess we're going to assume that the husband makes a little bit more than the wife. So what that means is that for each data point here, let's say we're here on the wife's income. Then we're going to go, let's see, if we're here on the wife's income, we're going to go up this amount. That would be doubling the wife's, or that would be equal to the wife's income. We have to double that, but then go up a little bit to get to the family income, right? Because you double it, but you add a little bit because the husband makes a little bit more than the wife. So like that. And then if you're out here, you would double that and then go up a little bit, but it still should be linear. Now, I mean, I don't know how well you could predict this, though, because, yeah, I think in general you would find the husband makes more than the wife, but, I mean, in the year 2025, that's not that rock solid of a prediction. And then even if the husband does make more, I mean, how much more? So, yeah, maybe 50 years ago, in a case like that, it would be pretty close to 1. But even in that case, it'd be hard to say. Because, yeah, if 50 years ago, you might have a really steep slope here, but still, how much more does the wife make than the husband? It'd be hard to say. So somewhat positive. It would definitely be positive for sure, because the if they're both working, well, then 100% it's going to be for the wife's income. It's going to be the family income is going to be greater than that. But exactly how much greater would be hard to say. So somewhat positive. Okay, among couples whose family income is in the range $80,000 to $9,000, the correlation between wife's income and husband's income is, so, okay, does this give us some information? The average family income was around $85,000, and 10% of the couples had income, had family income in the range $80,000 to $90,000, so 10%. This is right around the average. So since we want to think about that, we're right around the average, so there's not going to be any kind of crazy stuff going on where you might have some special cases where the wife makes a lot more than the husband, which on average you wouldn't think that would be the case. So around the average, we would think that, so wife income to husband income, you have the 45-degree line where they're equal. You would expect to go for any given wife's income around the average to go a little bit above this, but I guess it still would be close to 45 degree. Or it could be that the correlation is around the 45-degree line, but it's just a spread, right? Or maybe it's no. Okay, I think we would expect in general to the husband to make a little bit more, even in 2025. So we put a line just above, and we'd be correlated around that line. It'd probably be pretty loose. Or wait, I think I'm reading this question wrong. So okay, no, we're looking at this plot would be only the families that make $80,000 to $90,000. So let's say this is 85,000. So in that case, if the wife technically, let's say, doesn't make anything, right? Then we'd be here. Then we'd be going down, because we have to always add up to, here's the wife's income. If the wife makes more, the husband makes less, because this plus this is going to add to 85,000. So in that case, because we have this constraint of total 85,000, then yeah, this is going to be a very linear, because once if you know, yeah, this is going to be very nearly -1, very close to -1, because if you know that the total income is between 80 and 90, well, then you know that if you know what, in that case, if you know the wife's income or the husband's income, well, then you know it's going to add up to something around 85 or 80 to 90. So because of the constraints here, this is going to be a close to -1 correlation. Because if you know, okay, again, you know the wife's income is 45,000, well, then you know, okay, if that family makes something between 80 and 90,000, you have a good idea of what the husband's income is going to be. Okay, true or false, and explain. If the correlation coefficient is 0.90, then 90% of the points are highly correlated. False. We talked about this when going through the textbook. We at the moment, we don't want to be looking too deeply into what the correlation coefficient quantity means. We're going to get into that later. So no, we don't think about it like the correlation coefficient is 0.8. We don't look at that as 80% of the points are tightly clustered around a line. Or it doesn't indicate that if you had a correlation coefficient of 0.9 and then a correlation coefficient of 0.1, that doesn't indicate 9 times as much linearity, let's say. So like right now, there's no direct way to interpret the exact numerical value of the correlation coefficient. We're going to be doing that more in chapters 10 and 11.